Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we are working together. Today is our lesson number 34. We are on page number 98. The very first problem that you see there on page number 98, problem number 152, as you can see, is already on the blackboard. I'm going to read the problem to you, then I'm going to get out of the frame. I insist that you do the problem yourself and then compare your work against the work that we'll do together, as we always have been doing. Here we go. Number 152, we are told that there are fewer than 8 non-zeros between the decimal point and the first non-zero digits. I'm going to read one more time. We are told that there are fewer than 8 zeros between the decimal point and the first non-zero digits. The question simply is, based on that fact, which could be the value of t? And this is the expression here. T divided by 1000 raised to 4. T divided by 1000 raised to 4. Can t be 3, 5 or 9? And here are the answer choices: none, 1, 2, 3, 2 and 3. Okay? And before I stop talking, before I fall silent, let me explain to you exactly what I mean by there. There are fewer than 8 zeros between the decimal point and the first non-zero digit. Let me give you an example of it. For example, here we go. Here's the decimal point: 0, 0, 0, 0, 0, 0, 0, 152, because it's question number 152. If you had a quantity like this, this is what they're talking about. Because this quantity has fewer than 8 zeros between the decimal point and the first non-zero digits. The first non-zero digit in this one is this guy. And between the decimal point and the first non-zero digits, we have 1, 2, 3, 4, 5, 6, 7. We have only 7 zeros. We have fewer than 8 zeros between the decimal point and the first non-zero digits. Go ahead, do it yourself. Let's see what we can do, shall we? Let's begin with 3. Let's begin with 3, obviously, because 3 is the first one there. Question is, can this t be 3? Can this t be 3? 3 divided by 1000 raised to 4. Would that work? Let's find out, shall we? 3 raised to 4 is same as 9 squared, which is 81. So we're dealing with 81, and 1000 can be written as 10 raised to 3, and then we have a power of 4. Let's see what happens when we expand it. So that's power of 12. That gives us 81 over 10 raised to 12. That's what we're dealing with. If we write it out, this decimal, this is what we're dealing with. 0 and then the decimal, and it is 10 raised to 12. And we only have 2 digits up here, which means we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 8 and 1. Because we need to move this decimal 12 spots. In 81, the decimal was sitting here. We need to move it 12 spots, and that's what we'll get. Does this quantity have fewer than 7 zeros between the decimal and the first non-zero digit? The answer clearly is not. It has 10 of them. There are 10 of them. 3, 4, 3, 6, 9, and 10. That does not work. Let's try 5, shall we? And if you had trouble understanding this problem, and if you were stuck there, you can pause the video now and try out the 5 and the 9 now. See what happens. Let's do it. Let's put a 5. 5 squared, 5 to the 4. 5 to the 4 is same as 25 squared, which is 625. And I hope you're able to see right away whether or not this is going to solve our problem. We have 625 over 10 raised to 12. 10 raised to 12 means we need to move the decimal place 12 spots. And we only have 3 digits on the top. We'll have a problem. There's your 0 and then a decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 625. As you can clearly see, it has 9 zeros. We need fewer than 7 zeros between the decimal point and the first non-zero digits. It does not work. Let's try 9, shall we? Hopefully 9 will do the trick. 9 to the 4 is same as 81 squared. So we have to figure out what 81 squared is. Keep your fingers crossed. Perhaps this will do the job. 81 squared. 1 times 1 is 1. That's an 8. 64. 1. We don't have to carry on. I hope you're able to see right away. This is a 16, 5. We have 4 digit answer here. 65, 65, 61 raised to 10 raised to 12. So what do you suppose is going to happen? We can only move it 4 spots. 1, 2, 3, 4, 5, 6. That brings it to 8. And now we have 4 digits here. 6, 5, 6, 1. That's what we get. Do we have fewer than 8 zeros between the decimal point and the first non-zero digits? The answer is not. We do not have fewer than 8 zeros. We have exactly 8 zeros. 3, 4, 5, 6, 7, 8. The question did not say 8 zeros. Question said fewer than 8 zeros between the decimal point and the first non-zero digits. And we have 8 zeros here. Not fewer than 8. It does not work either. The answer is none. Let's do the next one, shall we? Number 153. In 153, we are asked to create a 3-digit code for a lock. We have to create a 3-digit code for a lock, and those 3 digits that we are going to create for the code, they all have to meet certain condition. Here's the first one. The first digit, digit number 1 has to meet this condition. First digit cannot be 0 or 1. That's the condition we have to meet. The first digit of the code cannot begin with either a 0 or a 1. The second digit, we are told, must be 0 or a 1. And the third digit, we are told, the conditions for the third digit, is that the second and the third cannot be both 0. The second and third digit cannot be both zeros. I messed it up, but that's okay. Because we know in second digit we can only have a 0 or a 1. But if we put a 0 here, in the second digit, if we set the second digit to 0, then we can't use a 0 here. Because that's the condition is. For the third digit, the condition is that the second digit and the third digit cannot both be 0. Go ahead, do it yourself. The question simply is, how many possibilities are there? How many codes are possible? How many codes are possible? How many such codes can we create? Go ahead, do it yourself. Let's take a look at it, shall we? I need the room, so I'm going to erase all of this thing. We're going to start from the top. Go systematically, that's the key. Go systematically, and you always start with the one that is most restrictive. The most restrictive here is this guy. The second digit must be either a 0 or a 1. So let's take a look at it. We're going to look at two scenarios. The second digit has to be either a 0 or a 1. So let's pretend the first. I was about to say let's pretend, but there's nothing to pretend. The first scenario is that the second digit is set to 0. The other scenario is that the second digit is set to 1. Those are the only two possibilities, because the middle digit has to be either a 0 or a 1. Now we just have to figure out how many different possibilities are there. And there are 3-digit codes. So it's either this or that. Question is, how many different ways can we fill up the first digit? It says can be 0 or 1. It cannot be 0 or 1. There are 10 possibilities. When you set in the code, there are 10 possibilities. 0 through 9, 1, 2, 3, all the way up to 9. Obviously, I don't know why I saw the need to actually write it out for you, but you know there are only 10 digits. It's like on a telephone dial, there are 10 digits, 0 through 9. Oh, we can't have a 0 here, and we can't have a 1. That leaves us with only 8 choices. Second digit is already fixed here. We're putting a 0 there. So that's only one way. We're going to put a 0. How many different ways can we fill up the last digits? But the condition for the third one is that the 2 and the 3 cannot both be 0. 2 and 3 can't be 0. But here, the third digit is not a 2 and 3 cannot be 0. The second digit is not a 0. Oh, actually we are putting a 0 here. If second digit is 0 here, which means we can use a 0 here. Because 2 and 3 cannot be 0. So we can rule out 0 here. We cannot use a 0. 0 is out. But we do have 9 other choices. So that's one possibility. 8 times 9. 8 nines are 72. Let's look at this one here. How many different ways can we fill up the first spot? Well, the same exact thing. Nothing has changed. In the first spot, we can't have 0 and we can't have 1. That leaves us with 8 possibilities. And now, we are putting a 0, or rather, we are putting a 1. We are putting a 1 here. So there is only one way to fill up this guy. There is only one way to fill up this guy, the second digit. There is only one way to fill up the second digit. You either put a 1 or you put a 0. That's only one way. The question is, how many different ways can I fill up the last digit? How many different ways can we set the code for the last digit? How many different ways are there to set the last digit? With the last digit, we are told the second and third cannot both be 0. Second and third cannot both be 0. But we don't have a 0 here. We had a 0 here. This guy was a 0. This guy was a 0. This guy is a 1. If the second digit is set as 1, then there are no conditions for the last one. Because the only condition that you have to fulfill is that the second digit and the third digit cannot both be 0. But the second digit here is 1. Second digit was 0 here. Second digit here is 1, which means for the third digits there are no restrictions. There are 10 different ways we can set it. 10 different ways, because 0 through 9 are 10 digits. Very good, that's our answer. The answer is 72 plus 50. 72 plus 80. 70 plus 80 would have been 150, so it's 152. There are 152 ways that we could have set up these codes. 152. That was question number 153. Let's do 154. 154. In 154, we are told that we're going to mix two solutions of different strength. Mix two solutions of different strength. This one is this is 2% concentrated, and that one is 12% concentrated. And we are told that we are going to make 60 liters. We have to make a solution that is 60 liters in such a way that the final solution that we make by combining these two solutions, the final solution must have a concentration of 5%. That's it. Question is, what is the question? Number 154. Approximately how many liters of 2%? We want to find out how many liters, let's call it X. How many liters of 2% are needed? How many liters of 2% are needed? Number 154. 18, 20, 24. 18, 20, 24. 36 and 42. Those are the answer choices. Do it yourself. Okay, let's take a look at it. This question is a very simple. It's a very simple weighted average problem. And that's all it is. One quantity is going to have a weight of 2, the other quantity is going to have a weight of 12, and the final thing has to be 5. Let's see, how do we set it up? It's a simple weighted average problem. And we need 60 liters. The question is, how many of this we need? How many of the 2% solution we need? That's what we're calling it X. So if this is X liters, and we are told that we need 60 liters total, then this will be 60 minus X. 60 minus X will have a weight of 12%. 60 minus X will have a weight of 12%. And the X has a weight of 2%. There we go. And the final has to be 5%. The final thing that we come up with is 5%, and there are 60 of them. Because there are 60 liters. That's it. That's a very simple equation. That's what we have to solve. That's all it is. It's a very, very straightforward linear equation. Let's do it on the top. The rest is downhill. Let me rewrite it in a little bit better way. So that's 2x plus, I'm going to put this 12 in the front here, 60 minus x, and that has to equal 5 times 60. Let's open it. So we get 2x plus 12 times 6 is 72, and we have a 0 here, so 720 minus 12 times x is going to give us negative 12x, and that has to equal 300. Let's see what happens. We have a 12x here and negative 12x, that's going to give us negative 10x, would have to equal, we're going to bring the 720 to this side, that's going to give us 720 and 300 minus 420. There we go. That's all it is. The zeros are going to drop out, the negative is going to drop out, and x is 42. In other words, we need 42 liters of the weaker solution to combine with the 18 liters of the stronger solution. If we mix them in that way, if that's the recipe we use, then the final solution of 60 liters will have a strength of 5%. That was number 154. That was the last problem on the first column there. We're going to call it a day today here. Actually, no, let's do one or two more. Let's do a couple more. Problem number 155 in the next column. Here's the problem. Again, this is a very straightforward, simple problem, so I want to get out of the way. It says, if Jack loses 8 pounds, he will weigh twice as much as his sister. Together we are told they weigh 275 pounds. Now as in before the guy loses the weight. Here's the question. What is the Jake's present weight? Go ahead, do it yourself. And if you like, I can give you the answer choices. 131, 135, 139, 147, and 188. Those are the answer choices. Go ahead, do it yourself. Just do them together, shall we? As I said, it's a very straightforward, simple problem because we have two unknown, Jack's weight and his sister's weight, and we have two equations, two very straightforward, simple linear equation. The first equation is right here. Together they weigh 278 pounds. That's our first equation. But that's our second equation. That's the first equation. If Jack loses 8 pounds, well, let's make him lose 8 pounds. J will represent Jack's weight right now before he loses 8 pounds. So if he were to lose 8 pounds, then we are told if that happens, then he will end up weighing twice as much as his sister's weight. Let's use S to represent sister's weight. And twice that is this quantity. So if Jack loses 8 pounds, he will weigh exactly twice as much as his sister. That's our first equation. And here's our second equation. Together they weigh 278. Those are the two equations we can deal with, and that's all it is. Very simple, very straightforward. Let's see what we can do. So, let's bring the 2s to this side. J minus, we're working with this equation. J minus 2s. Bring the 8 to the other side. And here's the other equation. J plus S equals 278. I like to have my digits lined up properly. Let's see what we can do, shall we? Let's add the two equations. Let's add the two equations. When we add the two equations, you must remember, when we add the two equations, we're going to end up getting rid of Jack, but Jack is the one we are interested in. This answer choice represents Jack's weight. So we'll have to go back and redo that word there once we know the sister's weight. Let's subtract the second equation from the first equation. Let's subtract the second equation from the first equation. And now we know why I raised and wrote it there. J is going to drop out. Negative 2s and a negative s is going to give you negative 3s. A negative 278 and a positive 8 is going to give us negative 270. There we go. Divide both sides by negative 3 and S equals 90. His sister weighs 90 pounds. Luckily, none of the other choices say 90. Let's find out Jake's weight. Jake's weight is right here. Jake weighs 2 times S plus 8. 2 times 8 is 2 times 90 plus 180 plus 8 plus 8. 2 times 90 is 180 plus 8, 188. Very good. He weighs 188 pounds. Let's do one more. Number 158. This year we are told that our profit was $385 million. Or not the profit, rather, sales. Whether it's profit or sales, it really doesn't matter in this problem. Last year we are told that we had sales of $320 million. The question is very straightforward. The question is, what is the approximate percentage increase? Two, 17, 20, 65. Or 83. It's a very straightforward, simple percentage problem. They basically want us to figure out the percentage change from 320 to 385. This year we had a sales of $385. Last year we had a sales of $320. The question is, what is the approximate percentage increase? This is increase, I and C. Go ahead, do it yourself. Let's do it together, shall we? So going from 320 to 385, that's our baseline. This is our point of reference. Last year is the point of reference, obviously. Going from last year to this year, we have an increase of $65. And our starting point is 320. There we go. Don't waste your time trying to figure out the exact calculation. Don't waste your time trying to use the exact calculations. If they are going out of their way to use the word approximately in the problem, it's for a reason. They are telling you, just do the approximation. That's all. So that's exactly what we're going to do. Let's pretend that this 64. Let's pretend that this 65 rather is 64. Divide top and bottom by 32, and we end up with 2 over 10. 2 over 10 is 20%. That's all. As you can see, I went from problem number, we did problem number 155, and then we did 157, and this is 158. As you can see, we skipped over problem number 156, and I skipped over problem number 156, and that problem number 156 we'll do it tomorrow, and we'll do only that problem alone in that video, tomorrow's video, problem number 156. And when the tomorrow comes, you will see why we skipped it. Alright? I'll see you tomorrow. Bye now.